Here is probably the absolute most useful thing you'll learn for these properties, or I wouldn't say most useful, the most commonly used, okay, method to take a derivative. This one, you need to sit up and pay attention. You'll use this hundreds of times during the course of the class here. If you're taking the derivative of x raised to some power n, which n is in this case is a constant, so this could be x squared, x to the third, x to the fourth, x to the minus fifth. It could be anything up here in the exponent as long as it's negative or positive. It doesn't even have to be a whole number. It could be a decimal up there. Okay, how do you take the derivative of that? Well, it's going to look complicated, but it's very simple. You take the exponent, you put it down in front, and then you write x to the n minus 1. So in order to take the derivative of x to the nth power, you just put the exponent down here and put x down and n minus 1. If you were to really want to understand why that's the case, you'd have to spend some time looking at how that's derived. I don't plan to do that. You can go back to the definition of the derivative that we just talked about in the previous section. You know, the thing I told you that you probably won't use very much. What it's really useful for is to prove stuff like this, okay? My goal in this course is not to derive everything. I think the book's job is to do that. My job is to tell you what the results are and show you how to solve problems, how to use the stuff, okay? This is how you do this. Let's do a problem. This will become very clear here in just a second. What if you have f of x is equal to x squared? This falls in this category because it's x raised to the power of 2. Then simply f prime of x, which is the derivative, is 2, I'll pull the exponent down, times x, and in the exponent I have 2 minus 1, which is just like this, which is just 2x, because 2 minus 1 is 1, x to the 1 is x. So all you do is you take the exponent, you pull it down, you write x, and then in the exponent it's just, in this case, 2 minus 1, which is 1. So that's the answer to that. Another one, just to practice it, if you have f of x equals x to the minus 3, then how would you take the derivative? F prime of x equals, take the exponent, in this case negative 3. Here I'm going to put parentheses around it just to be clear. It's negative 3 times x to the negative 3 minus 1. It's the same formula. Negative 3, you subtract 1 off. So you'll get negative 3 x to the negative 4. Okay? Easy. Easy, 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 right? Basically what I'm teaching you how to do is to take derivative of polynomials. This is how you take, this is going to be how you're going to end up taking derivative of any of those polynomials that you've ever worked with. X squared plus 3x plus 2 plus 5. Okay, things like this. But just to do a couple more quick examples, if g of x is equal to 2 times x to the 5 power, then dg dx, the derivative of g with respect to x, is going to be, using this first property, it's 2 times a function of x, so I just write 2 down, because I can pull the 2 out, and now I just take the derivative of this part, x to the 5. So it's going to be times 5 x to the 5 minus 1, okay, which is 10x to the 4th. So really all I did is I moved this 5 down. It's got to get multiplied by this 2, which gives me the 10. In the exponent here, I've got 5 minus 1, which gives me a 4. The only difference between this and the previous problem is that I had a number out here. And technically, you're going to have to use this property to remember that this number just sort of stays out there, and I'm multiplying by the derivative of this, which ends up being 5x to the 4th power. When you multiply, you get 10. Now, at the end of the day, you won't ever have to think about using this property. It will become second nature. But this is the rigorous way in which you do it.